constraints of an algorithm. So it is proven that all the algorithms for the problems that can be solved on a computer can be constructed by just using three control structures. What are they? One is sequence, other one is selection, and repetition. Means what? Using these type of basic primitive operations, you can solve all the problems that can be solved by a computer. Okay, that means what? In programming, only these three types of basic constructs will be there to solve a problem. So how they look like? You can see here, sequence is the first category. Means what? Instructions will be executed one after the other. So first instruction, and then second instruction, then third instruction, so on, so. Means after executing this first instruction, so we are going to execute the second instruction likewise. So this is in sequence. Means either you can write in the form of sequence of instructions, or some instructions are designed to solve in a selection category. So what are that means? There will be some condition here, right? And based on this condition, let us say A is greater than B, let us say. If this condition is true, we'll follow the right hand side path. If this condition is false, we'll follow the left hand side path. Don't worry about this. I'll explain you in detail in terms of a flow chart, in terms of you can say pseudocode, in terms of even code also. Just understand, any problem can be solved using three types of constraints. So those constraints are, first is the sequence, second is the selection, and third category is repetition. When I say repetition, what does it mean? So this portion of the code or set of instructions will be executed again and again until some criteria has been satisfied. We'll execute all these instructions in this block many number of times until some condition has been satisfied. So these are the three constants of a algorithm. As I said, so this basically this is for just for your notes sake. So it's a sequence means step-by-step execution. So selection is addition making using a true or false logic. So it enables branching based on the conditions. And we have a repetition. It's a process of repeating actions using loops until some condition has been met. Okay, so this is only for your notes sake. Now, so when you are developing a program, you will have to follow some set of steps. So first is, you have to understand the problem. Means what that problem basically, what is the input it is taking, what is supposed to solve, what is the output we are expecting from this algorithm. So these are the understanding about the problem. And next is, once you understand the problem, we have to represent our solution, that we call it as an algorithm. So that algorithm in terms of a pseudocode or flowchart. Don't worry, I'll explain now what is pseudocode, what is flowchart. So whatever the problem we have understood, and for that problem we'll write an algorithm. When I say write an algorithm means what? You have given a solution to that particular problem, and that algorithm basically can be represented using a pseudocode or a flowchart. Why we need to have a separate pseudocode and flowchart means, these are easily communicatable to other programs, easily understandable by even non-programmers also. So if they are not computer science completely, they can easily understand by seeing this pseudocode and flowchart. So that is the main purpose of using these two different tools, right? So once you have written your represented your algorithm in terms of pseudocode or flowchart, we have to implement in a programming language. So basically those programming languages can be Python or C, any other language. Then we usually test or debug the program. When I say test or debug the program, whether it is working for all the cases where it's supposed to solve. So we'll test all those cases. We'll see that examples, don't worry now. We are going to solve problems based on these following steps only.